So, starting off the webinar this afternoon, we've got Ronald Siebes from BU Amsterdam, who is the pilot lead for the Big Data Europe project, and he is going to give us an overview of the Big Data Europe project and the societal challenges that it addresses. So, Ronald, I'll hand straight over to you.
Thank you, Kira. Thanks for joining, everybody. And I will try, as Kira said, to first give a little overview of Big Data Europe, and then present to you the societal challenges from the Horizon 2020 call, from which Big Data Europe is one of them. And then after this generic overview of the various societal challenges and the big data problems that are very typical in those 7 domains. Then Nick will take over and will talk about the pilot and the implementation and the strategies which are applied, and also Hajira Jabeen from Bonn, University of Bonn, will describe the Big Data Europe infrastructure, which are what is a selection of existing technology, big data technology, and components developed by the technical team in our project to make it easier for people to use big data technology in their domain. Okay, let's go. So Big Data Europe we are now more than halfway. We had the midterm review, and it is all about, as you might imagine, it's about big data, and it's not about the scientific. It's not a scientific project in the sense of that we are trying to do tackle various problems which exist currently in big data domain, but we are more a project that tries to reduce the complexity for people to use big data technology and to recognize problems that they have, and then can look up the blueprints that we are kind of developing for the problems that they are typical for their domains. So the Horizon 2020 call consists of 7 societal challenges, and for each challenge in our Big Data Europe project, we try to work together with the domain experts, which are part of our consortium, identify their big data problems, and try to come up with a solution, and also discuss this with the community outside our consortium, to come up with an easy solution, or at least a solution that doesn't require a lot of experts or money to invest in running, for example, a pilot which is very similar to their own domain. So the first societal challenges is life sciences and health, and that is what our societal challenge is about, and what this webinar is about. So I'll just give it a quick glance what we are doing. So probably given this audience of Open PHACTS, you were probably all coming from the Open PHACTS mailing list, so I assume that you are very knowledgeable, even way more knowledgeable than me, on what these data sets and data providers are meant. So it's all about compounds, targets, pathways, tissues, diseases. So what we do in this in Open PHACTS is that we looked at all those data sets and first of all connected them by making link sets between the various identifiers that represent the same entities but in various data sets, and then created an infrastructure that makes it easy for developers to use our connected or linked data. We did everything in linked data in RDF and semantic web format, but we wanted to abstract this complexity for the users, because you cannot really expect people to learn to do efficient Sparkle on the database. And Sparkle is the query language for linked data. All right, so in the end, our Open PHACTS delivered an API where you can easily register for free, and then you can use our API. And here's a screenshot of the various web services, which are kind of they are REST calls, as maybe you know what that means, which are just calls. You can type in the URL with the parameters, and then you get the result back in the format you wish for, which can be JSON or CSV or whatever. And there are a couple of output formats that we have specified. And the choice of these web services, so these calls, are based on 20 research questions. So the beginning of the Open PHACTS project, we had 20 research questions which were very typical for the domain of doing drug research. So if you are a drug researcher, you have these typical questions, and then it was, before Open PHACTS, it was quite tedious to get answers on these questions. You had to go through Excel sheets, you had to compare these identifiers, etc. And also, because it is quite time intensive, you could not do very complex queries which would require a lot of comparisons. So at the end of the project, so after Open PHACTS finished, we were also able to answer new research questions which would have been way too difficult, time intensive to answer before this project. Okay, so the next societal challenge from the Horizon 2020 call is food and agriculture. Oh, sorry, I go back one slide. What is the big data aspect from this societal challenge? Well, it is not so much the amount of data. So all these data sets, okay, there are gigabytes of data, but that is still not big data. The big data part is the reasoning part. So to connect all these linked data sets and to answer these complicated queries, you have to do a lot of reasoning. So they're all logical deductions. You have to calculate these paths between these in that graph, that linked data graph, and that is very computational intensive, and therefore we have Virtuoso, which is the commercial version of Virtuoso, which is quite an expensive database fitted for RDF data that runs on a cluster. So you really need a cluster in order to efficiently answer these queries, or a very expensive zillion core machine to do that for you. So that's the big data part for this societal challenge. So now we'll go over the other 6, but I will take less time for those. Societal challenge 2 is food and agriculture, which is in our case looks very similar to the first societal challenge. So we are working together with the Food and Agriculture Organization of the United Nations. They are part of the project Semantic Web Company and Agro. And this project, the pilot that we are developing, is focused on the viticulture. It's the science of wine and grapes. And as you can imagine, to produce a good wine for now and in the future, you have to be knowledgeable about the soil properties, the genes, the phenotypes, the climate data, humidity, viruses, blah, blah, blah. So that is a whole science in itself. And to do this science, you need to have access to all kinds of databases that provide ingredients to answer certain questions that you might have. So the reasons that we have this pilot is that the wine sector is very important for us, countries of our European Union. And also the climate change, we expect quite an effect to have on the types of grapes that are going to have problems if we don't do anything about it. So we might have to change the the grape types according to the changing climate. All right, so, and the big data problem here is the same as for Societal Challenge 1, namely combining, if you have all that data in linked data, in RDF, to do reasoning over these various data sets is again very time intensive, and therefore it is a big data problem, because you have to run, and if you want to have these queries answered in time efficiently, you need a cluster in order to compute a cluster to answer these. All right, so the energy is a very different one in our case. We have CRES, that is from Greece, and the National Center of Scientific Research, Demokritos, also from Greece. And there we have an energy, this is the energy societal challenge, and in this case there are experts who have wind turbines, and these wind turbines, they have all kinds of sensors inside in order to monitor various parts in that thing. These devices are very expensive, and if something goes wrong, something tiny, a little clutch, or I don't know, a little wheel is starting to shake, then if you shut down the thing on time, then it's not going to destroy the whole engine and catches fire. So you really want to prevent that. So you have all these sensors, and they produce loads of data. So gigabits of data per hour per turbine are being sent to a big cluster that does analysis over this sensor data. So this is a big data problem in the sense of the amount of traffic that is being produced by all these various turbines. Okay, so I go to transport. The transport societal challenge is similar to societal challenge 5. There we have Fraunhofer, we have CERT from Greece, and Ethico, where there are the pilot is here about monitoring traffic in order to predict congestions on the road. So here, mobility planning, mobility and traffic planning. They do that by having sensors in the road. They monitor the Bluetooth signals and all kinds of other data. And there you have quite a lot of data if all these sensors would be connected. And then you have to have a cluster that calculates real-time what will be the which road segments will be busy, let's say, in half an hour. So this is a big data problem on the amount of data that is being produced, but also on the calculation capabilities the server needs in order to calculate all these various bits and parts of the road segments. And they use neural networks, I think, now for that, which are also quite intensive. Okay, that was transport. Now we go to climate. In climate, I made this mistake in the slide. I'm sorry for that. In the climate case, we have these climate models, which are very big models calculated by supercomputers. And in order to do something useful with it, you have to downscale it. That's what they call it. So in the climate research, if you have these models which are being produced by these superclusters, you have to, let's say, fine-tune and downscale that enormous data set according to your needs. So if you want to do research on for example, in the Netherlands, you want to know what is the average temperature and humidity on 1 meter height above sea level in the Netherlands, and what is the average wind direction. So in order to have that to be able to extract that data, you have to downscale that large model that is being calculated, and that process is also very computational intensive. So you have to be able to first get that large data set, so it has to fit on your machine, which is not terabytes, gigabytes, terabytes, yeah, so 500 terabytes, I don't know exactly, but it's very large. And then you have to be able to manipulate that data. So you need a cluster in order to do that. Okay, so that's climate. Sixth one is societal social sciences, where we have information from, so it's partners at CESTA and Demokritos. And here we focus on budget spending on municipal levels. So we have all kinds of municipalities. They produce real-time or on daily basis spending data and then categorized by various parts. For example, one is environment, another one is security, safety, and etc. So, and then we want to have a platform where people can real-time see and do analysis on and compare various municipalities on various parameters. So this is for social sciences, very interesting to see which countries and which municipalities are spending more on what and why. Okay, last one is security. There we have Satsen as the domain expert, and they use a satellite that goes around the Earth the whole time and makes pictures. And the idea there is if there's somewhere an accident or somewhere there's a lot of Twitter messages, then in this case I show you two pictures. One is before and one is after. This is with the, I think was this with the refugee campaments. So another example is the earthquake in Italy. You want to see these, compare images as soon as possible, the day before the event and the day after the event, and then you can analyze if, for example, which buildings are collapsed or which roads are being moved and by how many centimeters. So this analysis, real time or as quick as possible of these satellite data is very data intensive, because the amount of data produced by the satellites is huge. So you also need a cluster to do that. So here again you have a vast amounts of data that you have to deal with. So this looks a bit like Societal Challenge 5 as well. So now I went through all the societal challenges. I think I took all my time. So I would like now for Nick to take over and talk about the pilot. Or Kira, maybe you want to.
Yes. Thanks, Ronald. Thanks very much for that, for explaining the background of the Big Data Europe project. So next we'll have Hajira Jabeen from the University of Bonn, who's a big data and semantic web researcher, who's going to be telling us some more about the infrastructure of the Big Data Europe platform and the components that are being developed and its flexibility and how it's being used to solve all of these different challenges. So Hajira, I will hand over to you. Okay.
Thank you, Kira. Can you hear me?
Yes, we can hear you.
Hello?
Yep, we can hear you.
Okay, thank you. Yeah, thank you very much. So I'm Hajira, and I'm presenting here the Big Data in Europe platform architecture that we've developed in the last 2 years. Yeah, the platform is being developed with very ambitious goals. That is, the platform should be open source, so it's accessible to everyone with no or least cost, and it should be simple to get started with big data tools and frameworks that are being offered within the platform and framework. And at the same time, we want to support a variety of use cases. As you've seen from Ronald, that there are very different types of use cases, and we want to support all of them on the platform. At the same time, there are lots of new technologies being developed in big data landscape every day, and we want to embrace these emerging technologies with time. And at the same time, we need to have simple integration with custom components required by our end user. So you might have seen this slide already that kind of gives you a picture of big data landscape, and we could see that trying to understand or trying to incorporate all of these tools from this landscape is not really straightforward. So this is the current view of the BDE platform architecture. This is how it looks like. And thanks to Docker, which is a very lightweight virtualization tool, it allows to wrap a component or an application along with all its dependencies, and it also allows to run those applications on any platform irrespective of the host execution environment. So it makes it possible to run anything as intended on any host environment. So we are using Docker as a wrapping or as a component packaging tool. On the other hand, Docker Compose is another tool which allows to create multiple Docker instances simultaneously. So you could create multiple Docker images, or you could run multiple Docker images at the same time using Docker Compose. And Docker Swarm is the resource manager which allows you to run these instances on a cluster of computer or on cloud. So we are making use of these three technologies quite generously in our platform. So whilst working with these tools, we realized that at some cases, or many cases to be precise, we need dependencies between different applications. For example, we have a Spark application which needs to read from HDFS HDFS Docker engine. So that means HDFS has to be ready before Spark tries to read data from it. Similarly, Spark workers, when try to connect to Spark Master, they need Spark Master to be up and running before they try to connect to it. So there are dependencies between different applications running in a pipeline or in a stack. So these dependencies were not catered for in Docker Compose. Therefore, we added some or custom components into this platform. So I would mention them one by one. The first is init daemon that allows you to create a workflow. So with init daemon, you can explicitly state that I want Docker, HDFS Docker to be up and running before Spark tries to connect to it, and then Spark Master should be running before Spark workers try to connect to it. So this init daemon enables you to create workflows within the big data pipelines, and it also allows you to create a pipeline of any type that includes Kappa or Lambda architecture for the big data. So yet another challenge was that most of the big data frameworks like Spark or Flink or HDFS and many others, they have their own web user interfaces. And once you try to use them separately, you would end up having separate web interfaces in different windows, and which is sometimes hard or cumbersome to manage. So what we do is we have created an integrator UI that combines these user interfaces into one with different tabs, and it also tries to give them same look and feel. We have also developed some other user interfaces like Pipeline Monitor, where you could monitor the status of individual component in the pipeline or in the stack that you're running, and many others that I will explain later. So this support layer is not compulsory. If you do not want to create workflows, you may opt out, and you may not use it if you don't want it. So it's yet another Docker running on Docker Swarm. So use of this Docker has enabled us to have a modular structure in the Big Data in Europe platform, and you can opt the components that you want, and you don't have to install the whole stack altogether. Another component is Semantic Big Data. There are two frameworks that are being developed within Big Data in Europe that I will explain in the later slides. So this is like a bit more in detailed view of the platform architecture. At the bottom layer, we have the hardware. It could be your computers on your premises or resources on cloud. Then as a resource management layer, you have Docker Swarm, and in that layer, we offer many frameworks like Hadoop, RDF, many RDF stores, or Elasticsearch, or Cassandra, and many others. In platforms, you can make use of Spark, or Flink Analytics, or Kafka message passing. And then we have our support layer that I've just described. And with this existing architecture, then the user creates his own application for Spark Analytics or for Flink Analytics. So that goes into the application layer. So for the moment, we are supporting a variety of frameworks for different tasks. For example, for searching, data acquisition, message passing, storage, processing, and analytics, or semantic components. So we've tried to cover many different areas of big data processing, but this is not the limit, as you would find out later that you could always extend this framework with custom applications and frameworks. So this is an overview of the Big Data Integrator Stack Lifecycle. For example, as an initial step, you would want to deploy the BDE cluster to your premises, or you want to deploy a stack to the existing cluster. In the second phase, you might want to monitor your cluster or the stack that you've recently created. And another phase is developing custom applications for the stack, or you want to package the applications that you have developed. For that, we have Docker images. And the next is BDI Stack Builder, or composition or integration of different packages that you have created in the previous step. And enhancement is that you want to include new custom components. For this, you need to include init daemon or integrator UI into your custom components. So BDI or BDE has provided a comprehensive set of instructions to follow if in case you want to include something new into the architecture. So in platform development, there are like different numerous phases. And the high-level picture is that you need to create a Docker compose.yaml file that describes the pipeline topology. This YAML file can be created from the components that are already provided by BDE, or you could include your own new components. And new components can be taken from existing Docker components, or you can create your own Docker component. And at the end, you could share them as a Git repository or on Docker Hub. That means that in such a complex pipeline, you might require different actors, like a person who's DevOps experience and who wants to set up the cluster. Then there is a developer who develops an application in Spark or Flink or using Flume or Kafka or any other tool, so on. Then there's someone who packages it for you, then someone who does the integration and then deployment on the cluster and monitoring of the cluster. But this is not the case for BDE. All these learning all these steps is very straightforward and easy, and it might be a matter of days, if not hours. So we have provided comprehensive set of instructions for platform installation. You could go to GitHub, and you can also follow screencasts that are presented on the YouTube. We've also given a set of instructions for development of existing components, and we've also provided some base Docker images that serve as a template for extension for custom algorithms or custom use. Similarly, for deployment of stacks, we have created some example pipelines or stacks where stack is a collection of communicating components to solve a specific problem as described before. And it has to be described within a Docker Compose file. Then you can enhance these components. If there are some dependencies, then you would like to use init daemon, that is, components might depend on each other and you want to require manual intervention during the startup so that it could follow a particular workflow, or you want to integrate user interfaces of different components together. At the same time, Big Data in Europe has also tried to facilitate user with multiple user interfaces, and these user interfaces are Workflow Builder, Workflow Monitors, Form User Interface, and Integrator User Interface. Workflow Builder allows you to create the workflow using a user interface. So you pull in Dockers from the BDE GitHub, and then you create a workflow that I want to set up HDFS first, and then Spark, and then populate HDFS with the data, and so on. Workflow Monitor allows you to monitor the status of the big data individual components and see which of them are running, have they finished, are they starting, ready or not, and so on. SOM UI allows you to scale up or scale down the Docker components present in the running on the Docker Swarm. So, for example, you could increase the number of Spark workers if more processing is required. This is another view of Swarm UI. And Integrator UI allows you to see multiple user interfaces from different frameworks on under the one integrated user interface, giving you same look and feel. So apart from creating a platform for big data frameworks and tools, we are also working on developing frameworks for big data. So our notion is smart big data, like increase the value of big data by adding meaning to it. One of them is Semantic Data Lake that we call Ontario. So the main idea is that mostly repositories are resulting in data swarm. That is, a repository of data is in its raw format, and all the data, either structured, semi-structured, or unstructured, is being dumped at the same place, and it's schemaless. So Data Lake adds a semantic layer on top of these data sets, and it semantically lifts the data set using existing ontologies, which allows you to query this data, which is actually in different formats, and perform meaningful analytics for it. The other is Scalable Semantic Analytics Stack, SANSA. So it tries to combine the best of two worlds. For traditional machine learning libraries, they work on structured tabular data which require a feature set as an input. On the other hand, the semantic web is an expressive modeling technique that allows powerful integration of different types of data together. But the learning or machine learning for semantic web data is not it's not scalable so far because of the complex structure of the underlying data. So SANSA tries to combine both of these, and it offers 3 different layers. One is RDF representation and distribution layer. Then you could query this data, you can perform distributed inference on top of the data, and it also allows you to perform machine learning on the semantic data. So this is the overview of the layers being offered by SANSA Stack. So RDF representation, querying, inference, and then on top of this inference, we have multiple machine learning algorithms or analytics algorithms like classification, link prediction, clustering, anomaly detection, and so on. So yeah, this is it about the Big Data in Europe platform and the frameworks that we are being developed within it. Thank you very much.
Thanks very much, Hajira. As I said, we'll keep questions to the end, so we'll go straight on to Nick's presentation. So Nick Lynch is the CTO of the Open PHACTS Foundation, and will be giving us some information on how the Open PHACTS platform has been implemented on the Big Data Europe infrastructure as the pilot project in the Societal Challenge 1 for health. So Nick, I'll just hand over to you.
Thanks very much, Kira. And thank you very much for Ronald and Hajira for some great presentations. Given given what's been explained before, I won't spend too much time on Open PHACTS, the project, but more talk a little bit about how Open PHACTS and BDE have been working together over this last period. So I'll just put my slide deck into presentation mode if it obeys. Hopefully that's visible in presentation mode. So firstly, I want to give credit very much to what Stian Solon-Rees has been doing within both the Open PHACTS project and other projects that he's working on. He very much created the sort of platform that we're using around Docker. And as I say, he's done a lot of work both for Open PHACTS and also in BioXL, and is based at the University of Manchester in Carol Goebel's group. So given that you've all heard a little bit about the role of Open PHACTS, our real focus is on bringing different data sources together, both initially those data sources that are from the public domain, some of those that are listed at the bottom, some very popular data that support the life science workflows around pharmacology and patent targets and diseases and pathways. And equally going forward, allowing that data to be integrated with internal data. And in a way, that drive of the integration with internal data or private data was very much the initial work that spurred us on to have a Docker approach right from the beginning, because of the potential need to take what was a publicly accessible Open PHACTS and allow someone or an organization to bring it inside their firewall and start to work on it in terms of bringing in their own data. So Docker has very much been part of the sort of design and architecture of Open PHACTS now for a couple of years. What I will just do in the next sort of 5 or 10 minutes is just give a little bit of a history of what we've tried in Docker and some of the learnings, and likewise, if you've got more questions on that, please get in touch and we can try and answer that. Equally, we want to talk a little bit about what we've done recently around transitioning to Amazon and some of the benefits of continuing using our core components, but the ease that Docker gives us in moving between different platforms. And then I'll just briefly mention some of the next steps for Open PHACTS around data refreshes and plans going forward. So you've probably seen this slide already, so I won't dwell on it, but I really want to emphasize the breadth of data sources that we have in Open PHACTS, and that this is one of the challenges that we've been thinking about how Docker could help us with in terms of being able to manage some of the data refreshes going forward. So I'll pick up some of that in a minute. So the most popular way of accessing Open PHACTS is in a couple of ways, both from our public API, and we've been able to replicate that within the Docker approach. And then secondly, to work with it from an exemplar web application that was built as part of the project by Ian Dunlop and others. And this allows someone who is much more keen to look at data there and then, rather than perhaps rather than use the API and perhaps push it into other workflow tools. So the role of Explorer is to give people that easy access to the data to present it in a way that is similar to some of the tools they might be using internally. A little bit about how we've been working with Docker over this period. And I'll also mention some of the benefits that we've seen just in the last few months in our recent work with transitioning to Amazon. So something that you can look back at later, but this is the basic sort of cartoon of our architecture from the top in terms of our API that I mentioned, all the way through the different sort of data formats. The RESTful interface that we use supports a range of data format as export. And then really the heart of the system, as Ronald mentioned, for some of the other big data projects, we use Virtuoso 2 and have been using it right from the beginning of the project. and we load our data graphs into that. We have a couple of other components that aren't sort of pure graph or triple based, but that support some of the key aspects of drug discovery, both identity mapping and identity resolution. And as Ronald said right at the beginning, we've been trying to cover a number of core drug discovery questions through the delivery of Open PHACTS. And a lot of those questions do rely on people being able to map between different data sources which may well represent an entity using a different identity or different, and so identity mapping really is at the heart of what Open PHACTS does. And we have something that was based on BridgeDB for that. And similarly, identity resolution of being able to go from text to URI has been another big part, and we're currently looking at revising that and looking to use things like Elasticsearch to help us with managing labels and getting good text to URI out of the system. So certainly welcome any feedback on that going forward. So our core platform is all about answering those core questions and being able to provide an API, a public API, out to people such that they can then include Open PHACTS data either in their workflows such as KNIME and Pipeline Pilot, as well as custom applications that have been written in the past or could be written within particular organizations to support particular questions and challenges. One thing it's worth bringing out is the sort of the workflow that's applied to data sources. So we work closely with all our data providers that I've mentioned and that's been one of the goals of the project, was to encourage broader usage of RDF. And in a way, many of the data providers now are providing that as a standard. So Kemble and Uniprot and many others have really supported the move to RDF, which is perhaps underpinning some of the future BDE efforts too. So this is just a quick schematic of how we work with the data. One core part that I haven't mentioned so far is the chemistry search. So we bring together all the chemistry structures within Open PHACTS and align them and normalize them such that they can be queried in a uniform way to then marry that type of query with the rest of the non-structured data. So that we almost have a two-part process to querying if it involves chemistry. And that's then, most of the graphs are loaded into Virtuoso, as I mentioned, and we're equally using these identity mapping and identity resolution services to support the different API calls. So, as I mentioned, Stian worked a lot about over 2 years ago now in bringing Docker into the project, and we've been able to share, work closely with BDE over that time. So this is just how it's exposed on the Docker Hub website, and people can pull down the images, the Docker images that Hajira mentioned the overall goal of Docker before. So we've gone down that model to support people being able to sort of access our Docker images. And I think one of the important learnings that probably Stian was able to do was that he broke down the overall Open PHACTS architecture into a number of separate Docker images, which makes the updating of those much easier than having one single image for all of Open PHACTS. So as well as breaking down the sort of core application part stack of Open PHACTS, we've also broken down the data part of Open PHACTS too, and I'll touch on that in a minute. But I think the main benefits of that has really been seen in this migration to AWS recently, that it was actually very easy once we sort of got access to Amazon to transition something that we worked on in Docker to being able to host it on Amazon. There are obviously some glitches in any transfer, but Docker was really helpful, and we were able to maintain the same Virtuoso instance in the sense of not needing to work. That part was equally easy too, of transitioning to Amazon as well. So it really shows the power of being able to take something that's been developed in Docker and move between different hosting platforms and still maintain the same service levels. So I mentioned a little bit before about how Stian had broken down the data into Docker images as well. And that's probably something to reach out. We'd love to hear people's feedback on this. So just a little bit of background on what you get when you get the Docker images from Open PHACTS, and some things you need to be aware of in terms of storage needs. So obviously these are quite large data sets, but I think the key here is that once you've got the process in place, having a Docker image for each of your data sources works quite well within the workflow that we've got. So we again have set up an image for each of our core data sources, and then that allows you, as you're deploying Open PHACTS in your own environment, you can pull those down just as you would pull down the other components that make up our platform, or as you would with other images that come via Docker. And it does make the whole install process easily scriptable over a period. We also have built in some versioning, so that was another thing that Stian was quite concerned about at the beginning, of making sure that we could verify the packages that we were setting up under Docker. And so we're using JFrog to help us with this. And this seems to have worked quite well, but we're certainly sort of exploring this more as we plan to do future refreshes and updates. So I think, one of the things we'd certainly encourage you to try, as with the rest of the BDE platform, is if you have an interest in the life science healthcare area, to try and install it. And there are some links to the platform at the end of the deck. What we can say is actually that the needs of a fairly basic install are actually quite modest, and I think there are ways that you can use this, not necessarily needing huge platform, but these are some sort of things to think about. This would certainly get you started in terms of working with Open PHACTS, but obviously that will depend a little bit on the type of questions that you run against it. What Stian has done, and this is again available on both in this deck, which is available afterwards, and also on the website, some quite detailed instructions for working with that. So I won't dwell on that today, but that these things are available to browse and to follow in your own time. So there's some good step-by-step instructions there. So just to recap and to bring it up to the current status, so this would be Explorer running on a local host, a host that you would have installed through Docker. And similarly, here is the API that then would be running internally. This looks a little bit different to the public one because it doesn't need the 3-scale here if you're running internally, but you can access the same services and the API calls look the same. And then the other benefit of working this way is that you get a Sparkle endpoint, so this would allow you to use the Virtuoso Sparkle endpoint directly for more custom queries that the API doesn't support. And just to bring you up to date on what we're planning to do at the moment, we're currently planning or working on a data refresh to basically go through a phased approach for refreshing our data. And that will include all the current data sets in a sort of staged approach. We're also looking at the wider architecture of Open PHACTS at this time, and certainly welcome your feedback on that. And we've also been focusing quite a bit on workflow tools. So we have a webinar coming up in the 24th of April that you'll, again, would be most welcome to attend, and it would show you a little bit about how we're, in a way, exploiting the data that's within Open PHACTS and within the whole BDE environment. And I say, the future things that we're thinking about at this point is potential of microservices and perhaps custom data staging, which will come from a bit more learning about how we could use Docker for that. And obviously the work, I know Stian has been using the Open PHACTS arrangement within the BioExcel project as well. So they've been looking at molecular simulations and using Open PHACTS as a data source for that. So just to recap and give you some links if you want to follow up. We have a downloadable Docker images, which we will be updating over the next period with those refreshes. And if you have any questions on Open PHACTS, then we'd be happy for you to get in contact. And thanks once again for the chance to present.
Right, well, thanks very much, Nick. So we've still got a few minutes left. If anyone has any questions, there is a chat box and a question box that you can send a message through the GoToWebinar interface. So if anyone else has any questions or comments, or if any of our presenters would like to add anything else. Oh, so I've got a question here from Ian Harrow, which says, how does the identity mapping service maintain the mapping? So I think, Nick, is that one for you then?
Maybe we need to just perhaps understand the question, Ian. Do you mean in any differences in mapping when you work internally or in general? I'll perhaps, I don't know if you can unmute Ian, but I'll perhaps try and guess what your question is. I think
he said curation or automated.
Okay, I think just to perhaps to build on that, so we will be doing updates to link sets at the same time as we're doing updates to data sources. So we will be pushing those out, and that they will also come as Docker images, so those can then be loaded into the core IMS at sort of core at key sort of version points. So that's how we will sort of maintain the mapping as the data sources change, if that makes sense.
Okay. Okay, Ian says okay, so thanks, Nick. We've also got a question from Pantelis Natsiavas, who says, initially it was mentioned that the big data aspect we're trying to cover through migration of Open PHACTS to the BDE platform has to do with the reasoning process. Could you please tell us a bit more on that? How is reasoning process facilitated by having more instances of the Virtuoso run in a cloud cluster?
Okay, I think I can answer that one. So by moving first of all to Docker, it allows us to easily replace the Virtuoso reasoner with other reasoners, especially given the fact that Virtuoso, the cluster version, is the commercial version, and there you have to fork out quite some cash to have the cluster version actually from Virtuoso. If you have the open source one that doesn't run on the cluster. And given that we made it in Dockers, we were already able to replace Virtuoso with a new revive of the of Forstore. Forstore is a cluster-based Sparkle endpoint that does reasoning, but also we have, as Hajira already mentioned, you have SANSA, who has their own distributed reasoner, and there are various other ones that we are currently testing. So what does to answer the question about actually the relation between Open PHACTS and moving to the Docker and then to Big Data Europe, is that we have the ease of replacing the commercial version of Virtuoso with other cluster versions that does do the reasoning. So it's not about multiple instances of, for example, the Virtuosos, but to have a cluster-based reasoner, which is, for example, done by Forstore. Does that answer your question?
Pantelis says thank you, so I assume that does. Yes, yeah. Thanks. Okay, we've still got a couple of minutes left if there are any last questions. It doesn't look...
One other one from here, right? Curation or automated?
Yeah, Nick just answered that one before. Sorry, that was a follow-up comment from Ian.
Oh, sorry.
Okay, well, it doesn't look like there are any more questions. So in that case, again, thank you very much for attending. We will be putting the slides and the recording up online and sending out a link to those. And of course, if you have any more questions, you can get in touch with any of us by Big Data Europe or via the Open PHACTS Foundation. So thank you again to Ronald, Hajira and Nick for their presentations today. And I hope you all have a good afternoon.